Okay, this is the recording of Lab 16. Lab 16 or Experiment 16 is on JK flip-flops and D flip-flops. Actually, this should be swapped around because we're going to do the D flip-flops or D latches first. These can be made to flip-flop, and we'll show you exactly what that means. But this is going to only be on the 74 LS74. So this is what we need, TTL signal generator. We're going to use the signal generator that's on the trainer, dual trace oscilloscope, a 5-volt supply. We'll use the 5-volt supply that's on the trainer. We're going to use a 7474D type. This should say edge triggered D type latch. So, and we need to learn the difference between these two. So this guy right here is actually an edge triggered. Edge trigger D type latch. And we're going to use what we call a bistable latch, so we'll understand what that means. And then a 7476 JK flip-flop is what we talked about. Of course, we're not going to use the resistors, we're not going to use this and not use this, and we're going to use the switches that are on the trainer. So what you're going to do now is you're going to log into Blackboard. Make sure you log into Blackboard, and then on the left-hand side in the main menu, you're going to go to data sheets, and you're going to fill in the pinout for the 74LS74. The 74LS74. There's actually two latches inside here, or two D-type latches, edge trigger latches in here. And every one of them that belongs to the first one, let me show you. Let me bring up the data sheets, and then that'll probably be easier to do. So this is the data sheet that's on Blackboard, and we're using the 74LS74A, I think, and this is the pinout. Okay, so it's got two latches on them, and all the signals that belong to latch 1 are used in the preceded by the number 1. All the signals that belong to latch 2 are preceded by the 2. So, but when you do your pin out, of course, you're going to have to send a 14-pin dip. Of course, pin 14 is DCC, and pin 7 is our common connection. So what you need to do is go in and fill that. Now, this is the drawing. Once you get back from drawing that, so you should have paused the lecture until you could come in and fill out your pin out. Excuse me. What we're using is we're going to be using latch number 1. So you need to go ahead and write the pin out on this diagram right here. By the way, this is and you got to learn this because different manufacturers, especially when you get the D's and the Q's and the not Q's, will always be the same for a D-type latch. When we get into your other control pins, these are going to be given slightly different names, and we discussed this in class. But S, this could be called set, which is what this is saying, and this is going to be equal to what we refer to as reset. Or preset, excuse me. So I think on our pin out, they're calling this PR. So that would be the pin that we're going to use here. Now down on this one, this is going to be referred to as either reset or it might be referred to as clear. So I think on the data sheets they're referring to this as the clear pin. Of course, we're going to use clear 1, and we're going to use preset 1, and then you can go ahead and fill in the pins, the pin out over here. Now, of course, since I'm doing the circuit, I am grading these things on, actually you're following procedures and filling out the pin outs that you're supposed to. So that's what you're primarily be graded on. So these are going to cost quite a bit just to do this. Now what I'm doing, this is, of course, we've talked about this. This means this is clock. So they're calling this clock pulse here on the data sheets. This is called CLK for clock. And we know it's edge triggered. And since it don't have a bubble on it, we know it's edge triggered on the rising edge. So what we're going to say about this thing is we're going to say Q follows D on the rising, only on the rising edge of the clock. And we'll see this when we go back to the data sheet and look at the truth table. Okay, so go ahead and you do your pin out. What we're doing here is my clear. I'm using switch 0 on the trainer. On my D, I'm using switch 2 on the trainer. On my clock, I'm using my pulse because we have problems, and this popped up in class where this thing would bounce and it would pick up bounce. So we're using the pulse, the switch label pulse, but these are actually debounced, and we talked about this in class. So these are debounce keys. So this allows our clocks to be really, really clean. So here I'm using one of the pulse inputs, and down here for my reset, I'm sorry. So here for my set, I'm using switch 1. So I got that wrong a while ago, guys. And then on my reset, I'm using switch 1, switch 0. And over here, we're using LED 7 for our Q output, and we're using LED 6 for our not Q. So go ahead and pause the lecture and come back and do the pin outs on yours. Like I said, we're using latch number 1, which I think all the pins are on the left-hand side, So here is the actual circuit. So here's the actual circuit, okay? And of course, what I'm doing is, here's the pulse. So this is an edge triggered. So we looked at contact bounce when I use these switches right here, and it gives us a problem. So this is my digit bounce key. This goes to my reset. This goes to my clock. This goes to my reset. This goes to my set or preset. This is reset or clear. This is preset or set. And here's my D right here. And you can actually see the Q and the not Q over here, my two LEDs. So what we're going to do is we're going to follow along with the lab. And let me bring up the actual truth table, and let's make sure we understand the truth table. So here's the truth table for an edge triggered latch. So what we're talking about, this guy right here, so this is indicating when it draws that arrow up there, this means it's looking for a rising edge. So we'll come over here and do a pulse. So if we come over here and we do a pulse, so this is low, of course, and this right here would be the rising edge. And this right here is what we refer to as the falling edge. So this guy, what we're going to say is we're going to say Q will follow D on the rising edge. So nothing's going to happen on this guy. It's only going to happen on my rising edge. Then what we find out is these, so the D is what we call a synchronous input. So when we use the term synchronous, we mean it is timed with a clock. So that's why this guy's got this clock pulse right there. So that means it's timed as a clock. Now what we have on this guy is we have two asynchronous input. So asynchronous inputs means they are not timed with the clock, which means they can occur anytime, any place, anywhere. Okay. Now when we notice the preset and clear is even on the diagram means they're low active. So when we preset the latch, we should see Q go to a 1, and when we clear the latch, we should see Q go to a 0. And of course, not Q should be just opposite. And this is what they're going to show you. These guys have priority over the synchronous inputs. So we'll see that in a minute. Okay. So, and we notice that when I come out, so first thing we're going to start doing, and we'll go through the truth table, and we're going to do a little more, is that if I bring my preset low, and I bring my clear low, my preset low, and my clear low, then my clock and my D does not care. So if it does not care, that tells you the preset has priority over the clock and the D. And we'll show that here in a second. So it says I'm presetting the latch, so Q goes to a high and not Q goes to a low. Then the next step says, okay, I'm going to bring my preset to a high. I'm going to bring my clear to a low. My clock does not care. My clock input does not care. My D input does not care. Q will go to a low, and not Q will go to a high. So this is not right. This is just high. So we come over here, then we said, okay, I bring my preset to a low, I bring my clear to a low, the clock don't care, this don't care, both these outputs go to a high, and that little thing right there means I need to look for a note. So when I come down and read this note right here, it says the output levels in this configuration are not guaranteed to meet the minimum levels of V out. If the lows are if lows are present and clears are not VL maximum, furthermore, this configuration is not stable. That is, it will not persist when either preset or clear returns to an inactive state. So this guy right here we want to avoid, but it is one of our inputs, so it's showing that. Okay. So the next state we have is now the preset is high, so we're not trying to preset it, we're not trying to clear it, and now my other inputs, my synchronous inputs come into play. This says if D is high and I have a rising edge of the clock, then Q will go high and not Q will go low. But it required a rising edge of the clock. So this is what we mean, it's edge triggered. That's what the term means. And when we look at the symbol, we know it's edge triggered because we come over here and we see this triangle. So this triangle indicates that we have edge triggered. This thing don't want to write, guys. Now, if it had a bubble out here, right here, let's redraw this. And we come up here with a bubble. And this means that this is edge triggered on the low going edge. So this one right here without the bubble means it is edge triggered on the high going edge of the clock. And now the next condition in the truth table, we have preset high, so it means I'm not trying to preset it. We have clear high, I'm not trying to clear it. The D input is low. We have a rising edge of the clock. Q goes low and not Q goes high. Then the next situation we have is that here clear is preset is a high, clear is a high, so we're not clearing or presetting. But in this situation, my clock is a low, D don't care, and what this means right here, Q equals to Q out and not Q equals to Q out. This means we are latched. So latch means D will not, Q will not change. It's going to stay in this situation until my clock goes high. As soon as it goes high, whatever's on the D, because this thing is edge true. So here's the truth table. Now here's the ISO symbol here. Let me. So here's the ISO symbol, and what this means, instead of using the bubbles on the ISO symbol or International Standard symbol, then this triangle right here means low active. And still, we still use the triangle here, but notice how weird this triangle is. It's a right triangle. This right here looks like it's an equilateral triangle, but I'm not sure. So this is telling us that C's are low active, and this is saying Q is, when Q is high, and not Q will be active low. And that's what the ISO symbols use. So here we're back to the lab. So we're going to do a little more than the truth table. So it says for us, right off the bat, it says for us to bring the set low and the reset high, or the clear low and the reset high. Okay, so as we follow on, I'm going to bring this back out because so you're going to fill in this information as we go through this truth table. Okay. So what I'm going to do is I'm going to go back to my camera, and we'll go right through this just like the sequence says, and we might add a little more to it. Okay. So it says the first thing I need to do is bring my set low. So right now I have it reset, so I want to make sure I put it in this one so you can actually see it changes place. And I have my reset connected to this guy right here. Okay. So we're going to bring set low, which is switch number 1. So we should expect Q to go high. So we should expect Q to go high and not Q to go low. Okay, that's what happened. And what I'm going to do, guys, I'm going to show y'all this is don't care. So right now I've got my set to a low, and then I'm going to come over here on my D, and I'm going to flip this around, and I'm going to flip my clocks around, and you see nothing happens. So now that means that my D and my clock are don't care. Okay. So right now we just brought the set. This is the first one in our truth table. We brought the set low, we brought the set high, and we noticed that the clock pulse and the D input, they don't care. Okay, so what I'm going to do is I'm going to bring this high, and then I'm going to bring my reset low. So we should expect Q to go low and not Q goes high. Okay, and then what I'm going to do is I'm going to come over here on my D again, and I'm going to flip it all over the place. I'm going to come up here and flip my clock, and notice nothing happens because these guys right now don't care, which means you're set and you're clear, or your preset and you're clear. Or I'm sorry, reset has priority over your D and your clock. Okay, so those are these two inputs right here. Another thing we're going to do, just to show you this is my ambiguous state. It's not in the listing, but I'm going to come over here and bring both these low, and notice Q and not Q both went high. Now the problem is this guy's going to come out ambiguous. We don't know how it's going to come out, right? You understand that? So this is why we say this is an ambiguous state, because if we bring the clears and the preset off at the same time, there's no guarantee of how this thing would come out. And another thing, when I turn this thing on, this guy is going to come up in an ambiguous state, which means this guy once we figure out how this guy will come up, it'll come up the same way all the time, because one side of the latch will be faster than the other side of the latch, than the not Q side, the one that controls the not Q. But I might hook up the one right beside it, and it might come up cleared all the time. So let's see how this guy comes up. So this guy appears to come up set. So I'll come up here and just flip it on and show y'all this latch is going to come up the same way every time. I accidentally hit a switch. But the one right next to it might come up different. And you saw when I flipped the switch, it actually flipped itself over. Okay, so let's turn this back on and let's continue on with our synchronous inputs. So that's why we call this an edge triggered latch. So what it says, what am I going to do? So let's make sure, what we're going to do is we're going to set it first. So what I'm going to do is I'm going to make sure it's cleared so we can see this happen. So I use my asynchronous input. Now I have the D setting at a 1, and what's it waiting on? I'm not clearing it, and I'm not clearing it, and I'm not setting it. So what's it waiting on? Well, it's waiting on a clock pulse. Does nothing right here because that's a falling edge, and as soon as I let it go, notice it changed. And then now, of course, I can do this forever, and right, so now it's latched. Now we can change it. Now it's latched. Now we can change it. Okay. So if I hold this down and I change the D, notice nothing happens because because it's latched, right? Oops. How's it doing that? There we go, because it's latched. Okay, so now we have it set. The next thing we want us to do is they want us to bring the D low. And then we're going to apply a clock pulse. And it resets. So notice this guy right here. Hopefully you understand what went on. This is what we call an edge-triggered flip-flop or an edge-triggered D-type latch. So if we looked at the data sheets, we would actually see what it said. So it don't call it a flip-flop, or we'll look and see what the data sheets calls it. So let me go. So this calls this a D-type positive edge-triggered flip-flop. So it does call it a flip-flop, and I'll show you why, with a preset and a clear. But it's a positive edge-triggered flip-flop. Now, why they call it a flip-flop is we can set this thing up so it flips or flops or toggles with every high going edge of the clock. So what I'm going to do is I'm going to take off my D. So let me draw this out and I'll show you what I'm going to do. We're going to use exactly the same pin out. So we're going to come over here, and what I'm going to do is I'm going to not draw the presets and the clears over here because I'm not going to rewire those. What I'm going to do is I'm going to take the not Q, and this is why it gets the name. I'm going to take the not Q, and I'm going to feed this back around to the D input. And this is why, this situation right here is why it's got the name as a flip-flop. And of course, I'm still going to use my clock, and I still have this hooked up to the same pulse width. Got power hooked up and everything else. I'm going to pause the lecture while I do this slight rewiring. So I have it look like I have it hooked up like this. Now let's think about this. So let's just start it up. So I redrove this on PowerPoint, so it's a lot faster. So let's say this is a 0, and then let's say if this is a 0, that means my Q would be equal to a 1. Okay. So what's going to happen is right now I've got a 0 on my D, but what's it waiting on? It's waiting on a rising edge of the clock. So what I'm going to do is I'm going to go down, and then I'm going to give it a rising edge. Then my Q output would go to a 0, and my not Q would go to a 1. And that's going to put a 1 right here. On the next rising edge of the clock, then Q will go to a 1. Q will go to a Q will go to 1, not Q to go to 0. So every time I flip my switch, this thing is going to flip flop. So it's going to, and or it's going to toggle. Toggle means it's going to flip flop. So this is why this is also called a flip flop. So let's go back, and I'm going to bring up my camera. And what I have, all I did was take my off of switch 2, and then I ran it over here to the not Q output, just off my light over there, because I knew right off the bat that was not Q. And then I'm going to come up here on my clock input, and notice every time I pulse it, it flip-flops. So this is why it's called a flip-flop, and we'll look at some of the characteristics of this later on the JK flip-flop. We'll look at so the JK flip-flop is easier to toggle like this, to cause it to flip-flop, and we'll look at that later. So this is why they're calling this a D-type flip-flop, is because we can wire the not Q back into the D, and then this thing will flip on every rising edge of the clock. So what we're going to do is I'm going to put this up in 3 different lectures, so you can work on it a little bit, and then make sure you get through with one section, and then go ahead and do the other. So what we're going to do is I'm going to go ahead and upload this, and then I'm going to come back and hook up a 7475 and tell you the difference between the 7475 and the 7474. We know the 7474 is an edge-triggered D-type flip-flop. When we talk about a D-type flip-flop, what we're going to say is we're going to say Q is going to follow D. And now Q is an output, D is an input. So here we're saying Q follows D on the rising edge of the clock. If we're not using the presets and clears. Asynchronous. Asynchronous means these are untimed. So your preset and your clear, these are asynchronous inputs. They can occur anytime, any place, anywhere, right? You understand that. The asynchronous inputs has priority over the synchronous inputs. So if we go back and look at our data sheet, we'll see that when we talk about the asynchronous inputs, we notice that wrong tab. Let me bring this back up. We notice when we go back to the asynchronous inputs, it says that if the asynchronous inputs are active, then clock and D does not care. Now, synchronous, we've talked about this, means timed with a clock. So the D is timed with a clock. It requires a rising edge of the clock. Okay, so that means this is synchronized with a clock. And so your asynchronous input has priority over your synchronous input. Okay, so what I'm going to do is go ahead and upload this to YouTube. And what I'm going to do is I'm going to put a link similar to the other lab, since this is required. I'm going to put this on Blackboard. By the way, if you miss class, then you need to go on Blackboard, go to Labs, Lab Sheets, go to laboratory experiments in the main Blackboard menu and download your own copy of this lab. This lab is due at the start of Monday's class, which will be the 22nd. All right, so I'm going to go ahead and pause this, and I'm going to go ahead and finish